Hello everyone, I'm Mike, and this is Finally Animatronics. In this, our inaugural video, we're going to try to make this talk to this, and that talk to this, and that control this. So let's get to it. Meet Fido. Fido is a good dog, in the way that all dogs are good dogs. Fido is the first piece of what I hope will become a really cool animatronics display for Halloween. My first goal with Fido is to make him nod his head. Now, in order to make that happen, I'm starting from the beginning. So that's what we're going to talk about today. So my goal for this video is to control a single servo, a linear actuator, and just have it do some simple movements. So let me discuss for a moment the hardware and software I used in this project. And where applicable, if I had to purchase something, I'll let you know basically what I spent. And I'll include a link in the description below to where I went to buy components. The first is my MacBook Pro. That's something I already had, so I don't really count that towards the cost. On that MacBook Pro, I run VS Code as my IDE, my development environment, and there are some plugins, some extensions for that development environment that really help with the Arduino, platform I/O, and there's some Arduino drivers. All that is free. You can get that online and use the IDE and all the plugins. The next component in the architecture is the Arduino board. This is the heart of the system, really. While you'll be writing code on your computer, you'll be building it and deploying it to the Arduino. I got the Arduino R4 Uno R4 because it has Wi-Fi, and while most of the processing will happen on the Arduino, I do want to send messages to it from my computer, and the Wi-Fi certainly helps because you don't have to be physically attached to the Arduino board to send it a command. Surprisingly, this board is not very expensive. I think I got mine for less than $25. So, it's really an inexpensive way to get into playing with these types of components. Next up is the PWM controller. This is a board that takes standard signals and translates them into something that servos can understand. In this case, it can handle 16 servos. And again, this is a very inexpensive piece of equipment. I think I spent less than $15 on it and got it from Adafruit, which is a pretty common company to get these kinds of boards from. I'll leave a link in the description below. The last component I chose was a linear actuator, or a linear servo, and I chose it because a couple reasons. One, it has really good torque, and two, it stays very well in the last position that it was moved to. But this was not an inexpensive piece of equipment. This one cost me like around $110. I got it from a company called Servo City that seems really good. They're really responsive, and I would recommend them so far. But yeah, you don't have to spend this kind of money if you're just playing with something. You can get little rotating servos. There are places that make it really inexpensive servos, places that make servos for remote control airplanes and all kinds of things in the $25 range or something like that. But for the application I have, I thought this was the best choice. We'll see. This is a proof of concept, so I won't know until we actually get everything all hooked up. But that is the components that I have put together to put this proof of concept together. So let's stop talking about parts and let's get into some actual building. First, let's worry about all of the physical connections between the components. We start with the MacBook, and the MacBook connects to the Arduino board and communicates over USB. In this case, USB-C, so it's a pretty straightforward connection with the USB cable. There are several leads then that go from the Arduino board to the PWM, or the servo controller board. A couple of those handle signal, and then there's power and ground as the Arduino passes power on to the PWM circuitry. Lastly, the linear actuator just plugs directly into the PWM board. There's multiple slots for it to plug in. So the first thing we're going to need to do is solder some components onto our PWM board. It does come pretty plain the way you see it here, but it also comes with a bank of connectors for the servo to connect to that go here. It also comes with a lug for the external power here. And as long as we're going to have the soldering iron out, we should go ahead and solder some of the wires on that will connect to the Arduino board here. So I'm going to run through the happy path for getting this system set up, but rest assured there were challenges along the way. My soldering skills were rusty at best. My equipment wasn't necessarily in the best condition, and that added some frustration. And there were places where I just flat out made some mistakes. So even though in this video it may look like I just stepped through and everything was smooth, there were some, as I said, some challenges. I think I will create another video just with some of the mistakes I made and some of the things I learned, the issues I had, and how I solved them or intend to solve them. There are three basic components that I need to solder onto the PWM board, and two of them come with the board. The first is lugs for the servos, and each bank of these lugs can connect 4 servos. So I'm just going to do one bank for now. Here you see me soldering one of those on. Next are the power and signal leads that will connect to the Arduino. I'll solder these directly to the PWM board. There are push-in connectors on the Arduino side, so I don't need to do any soldering on that side. Note that this is power for the board itself. The power that will pass through to the servo we'll look at next. Next is the power terminal. I don't really have a good video of actually soldering it, but I just wanted to show it to you. This is where the actual power that gets passed through to the servo comes in, and that usually is more power than what's going to the board, more amperage too. And yeah, I do straighten it out a little bit before I actually solder it. At this point, we have almost everything we need to connect all the components together. I say almost because I do need to find a power supply. Looking at the data sheet for my linear actuator, I can see that it'll take 4.0 to 8.4 volts. And luckily I'm a hoarder, so I'm just going to dig through my power supplies and see if I have anything around 5 volts. Then I'll snip off the end of the power supply, strip the wires, and connect them to the power lug on the PWM board. Next, I'll connect the power leads and the signal leads from the PWM board to the Arduino board. Now to connect the linear actuator to the PWM board. If you look at the actuator connector from the side where you can see the metal connections, the pin on the left aligns with the ground pin on the board. The last part of the physical connection is the USB-C cable from the laptop to the Arduino. This provides power to the board itself for the Arduino, and that gets passed on to the PWM board. And it also can provide signal, and it's where we will download the actual code to the Arduino. Now I realized with my amazing camera skills that wasn't very easy to see what was going on. So let's take a closer look. Here on the Arduino board, you see that we have a couple signal connections here, and that's the SCL and the SDA connections. This is what talks to our PWM board and sends signal. As well, we also have power, 5 volt. We have a choice of 3.5, I think that says, but we have 5 volt and ground. And this is what actually powers the PWM board itself. I used a white wire here because I didn't have any black. So that's white is my ground in this case. And on the PWM side, so these just are the wires that we soldered in earlier, and you see corresponding ground and VCC, which is the voltage, and then for the circuit board, and then the SDA and SCL connections. And then lastly, you can see where I connected from the power supply. That piece of tape on there is basically marking the negative cable. So let's talk a little bit about the code. And I say a little bit because there's a lot going on here. I actually have a much larger project. As you can see, there's a lot of different components that are associated with finely animatronics. But I really want to talk right now just about the Arduino code, which is C++ code that is loaded onto the Arduino. So as you can see, or maybe is that I'm working inside of VS Code. That's my IDE or my development environment. And in there I have loaded, installed an extension called Platform IO IDE. And that is kind of a little bit of a management system for building and installing code to the Arduino. So yeah, here, what happens on the left is you see this icon show up, and that allows you to, build and upload code, like I just said. So first of all, let's talk a little bit about the code, just so you can kind of see what I'm doing in here. And I'm doing everything in the main or the entry point to the code. And so right at the top level, there are two functions that the Arduino will call, but when you upload this code, it immediately calls and runs the code, and it will run setup first one time to sort of set up the application, and then it will run loop, and it will just basically loop over that continuously, and that's what the Arduino does. So and I just put all of these commands right at the top level. Ultimately, they'll go into more dedicated directories and dedicated files for these commands. But for now, at a high level, I just stuck them all right at the top level. So here you'll see that the setup command, it opens a serial connection. This is the connection where USB-C listens, and then it primes the actuator. And then sends commands to the actuator, right? And you can see that these commands are like move some percentage, move 0%. That's how this type of actuator works. You send it a command. One type of command you can send is to move from 0 to 100%, and it will move to that position on the actuator. It's kind of nice because you don't have to detect where you are. You can just tell it to move to a position. So that's in setup. And then in loop, it just goes round and round, keeps going. There's nothing here that sort of kicks it out until you kill the program, or unplug the Arduino, I guess. And and some more commands to move a percentage, and then there's another command to move a certain number of microseconds, and then this move %0 resets it back to all the way at the beginning. I have this. You might actually hear this run a little bit in the background because I've already built it and run it once. So I'm going to power up my Arduino, and I don't know if you can hear that buzzing, but it's already running. But we'll go through the steps of building and running just so you can see it. So we go back down here to this platform IO. We say, hey, build that application. You see here, it's running through, successfully built. So now the C++ code is built into an executable, and we can upload to the Arduino. There we go. Didn't take very long. And so now the Arduino has this code, and it immediately starts running it. And what do we get? And there it is. I think that's all I want to cover for this video. I want to keep these relatively short, but I do want to thank you for making it to the end. And if you're interested, obviously like and subscribe. Otherwise, I will see you on the next one.